English.
Streaming?
Yeah.
So, hi everyone. Today I will be presenting about GitLab and Kubernetes and how to set up the continuous integration pipeline for your project. So I will start about why even use Kubernetes to manage your containers. Then I will talk a bit about why use GitLab or any other solution like that. And then we will get directly into it. I will be showing a little bit of code like in F# and some JavaScript and HTML, but those are the pieces that are not very interesting. This is not about like what's the technologies that you deploy, but it's about the deployment, how you do it, how you set it up in a way that it works for your probably agile team. So first of all, for me, I think Dockerizing applications is great, and building small applications, we can call them microservices, or we don't have to, and putting them into a container and putting them into cloud is like really useful way to do stuff. It helps you because the environment is always the same, and you can test it locally on your machine, and you can publish it to your customer, and they can set it up in the same way, and then you can give it to the consumers and they can use it also the same way. So no managing servers, no playing around with difficult environments, stuff that's difficult to set up. But on the other hand, as we break down the applications into multiple containers and we maybe run them locally in Docker Compose, it gets more difficult to reproduce the same environment in production or at the customer side and so on. And then also the variation between the different environments is hard to capture, and it's difficult to like update one of the components and keep the other stable and so on. So we are solving problems that a lot of people solve as well, and so that's why the container orchestrators started and were built, and one of them is Kubernetes. So that's this one. That's one part that I will be talking about. And then this is like on the ops side. That's where we deploy the application, where we monitor it, where we update, do rolling updates, and so on. And then on the other part is where we, as developers, sit, where we have some source control, where we push our code, and so on. And that's GitLab. If you know GitHub or VSTS, this is pretty much it. But this one is more complete, and you can deploy it locally. You can with the other solutions as well, but this one probably started the chain, and it's really nice to integrate it with Kubernetes. So that's why we will look at it. Where do we go now? So there will be a lot of setup or a lot of different moving parts. So first I will show you the end solution that I have, and it might be a little bit underwhelming because it's just few icons and few different deployments. But I find it very practical because what I wanted to achieve is to have different deployment for every branch. So when we develop, like in Agile team, we have issues, and then we develop on the issue, and then we have a topic branch that we push somewhere. And so I wanted to have an environment for that branch. So then when customer asks me like, what's the progress on this feature? How does it look like? How can I do it? I don't have to tell him, okay, I will deploy it for you somewhere. It will already be deployed. And our tester can also take it, look at it, tell us if it's broken or not, and then we can review the code, merge it, and ship it in production all automatically. And it also throws away the environment. So that's what we will be building. And that's what I will show you right now. So here's my master branch deployed. So it just does hello world. And then based on this master branch, I created another branch, or well, I created first a task here in GitLab, and created a merge request, and that automatically created a branch for me. And I made a few changes, did a commit, and then pushed an update. And so this is my first task. So instead of hello world, it's now hello smart. But those are two automatic, totally independent deployments that I can show to a customer. And if he wants to test it a bit further and I want to develop on it still, then I can just fork the branch and push it and just tell him, okay, this is your stable branch based on this feature. And then other people can happily just work on the first issue that's called Be Smart. And then there is another one which looks kind of exactly the same, but it is deployed like a front-end application that looks just like this. It has some HTML, and then this H2 text is populated from this REST API call that prints the hello world. And what I'm highlighting here is how do you set up the application together with an API, and you do it with just one image, because what I often see is that people build multiple images, one for each environment for the front end, and that's not something that I want to do. I don't want to do it with backend, and I don't want to do it with front end. I want the deployment to be independent of how the application works internally. So if this backend app accepts this call, then it has no idea that it runs on /API. I can tell that to the application externally, but I don't want to make that mandatory. Like everything that goes to this microservice has to end with /API or like /API users or whatever. That's what the composition should be doing. So what we need for this is that we have a Kubernetes cluster. We have access to GitLab. We can deploy it locally, or we can just use the provided service that's provided by GitLab. And then we need a Kubernetes cluster. That's what I said. We need a Kubernetes cluster somewhere in a cloud, and I deployed it in Azure. Because with MSDN, which a lot of us has access to, we get like 130 euros a month where you can play and so on. And I didn't see anything like that in AWS or Google Cloud, because there they just give you like $200 at the start and then nothing. So, okay. So this is my cluster. Setting up a cluster in Azure is really simple. You just click create resource, you select Kubernetes service, and then you just decide in which resource group you put it, how do you call it, and pretty much the biggest decision is where do you want to build it and on which hardware, like basically how much money you want to throw at it. And for that, there is a very useful tool that's called Azure Price. So working on limited budget, I want to have the most cheap hardware that I can get that still fits my needs, but it can be very far away from me. So typically the cheapest services are in East US. So what this enables me to do is to compare the prices pretty much based on where I am. So like we would be North Europe maybe. And then I, for example, want B2S, B1MS. How much is that? 2 gigabytes, that's too low. So maybe 2 cores and 4 gigabytes of memory per host. So if I have 3 of those, I would have 12 gigabytes of memory and 6 cores. That could be something that I would be able to do with and deploy quite a lot of services on it, because one, for example, ASP.NET Core service takes like 30-50 megabytes of memory and very little CPU. So here I can see that if I put this in East US, it will be the cheapest region and it will cost me 10% less. So for example, yesterday I was comparing my cluster that's running in East US with the cluster that Roman built, and he paid 4 euros more per 1 VM per month. So if you only have 150, then it is a difference between having 3 clusters and having just 2 clusters. Okay, then GitLab. Here you just register. You can even sign in with your GitHub. So I already did that, already prepared the whole project. And then I created a project and pushed some code in it, so I have something to show you. And in my current setup, for example, I have this operations tab, and I have environments, where I can see all the environments where I already deployed my code. So this is the branches that I have, and if I push an update, it will automatically update in the environment. And there's also this stop button, which is also automated in my setup. So if I merge the branch, it will automatically tear down the environment. Or if I want to do that before, then I can just click stop the environment. It will take all the resources associated with this environment from Kubernetes and tear it down. I will show you how to set up that as well. And so it's pretty clever. The integration between GitLab and Kubernetes is awesome. If you set up Prometheus server, you can have like metrics directly in here. You can see how many pods you have, how many different deployments, what's broken, where is like pods that don't start because you broke the code and it passed your test, but it wasn't able to start anyway, and so on. Yeah, there's a lot of stuff. I'm just focusing on the absolute basics, like basic setup for our agile environment where we just want to deploy once per branch so we can show it. So we also need some tools. So locally what you want to install is a Docker for desktop or something like that. You can also use like a Docker toolbox, but it's quite outdated. So if you want a Docker, then use Docker Desktop. You need Azure CLI if you are working with Azure, and then you need Kubernetes CLI. Installing this is pretty trivial. Every operating system has its own package manager. So on macOS you can use Brew, on Windows you can use Chocolatey, on Linux you can use whatever comes with it, something like apt-get or so on. So if I was on Windows, which I'm not right now, then this would be everything that I would need to run to set it up locally. So Azure CLI, Kubernetes CLI, that will then be kubectl, and then Docker Desktop so I can try and build my images. All right, so I will start with a small Kubernetes primer so you have idea about what I'm talking about. So who has experience with Kubernetes? Just one, that's great. So where's my, I don't have any slides, but I have those awesome charts which are generated from Markdown. Let's see if I can zoom it up a bit. So in Kubernetes, we can look at the deployment from two different perspectives. One of the perspectives is like from the deployment point of view. So what is a deployment and how do you build it up from small services and how do you compose the whole application together? So in that case, the smallest piece is the pod, and pod contains the Docker containers that run our services. A pod has typically just one container. You can have multiple, but typically you just have one, and pod is like the smallest unit in Kubernetes that you think about. Then once you have this pod, you probably want to have a replica set. So replica set just says, this is a pod and I want to have multiple of them. So when one of them fails, the other can take the work and I can scale out or scale down based on the load. And replica set is quite like manual. It's I would say not old school, but it's this like a system piece that you probably don't want to use directly. Instead, what you want to use is a deployment, and deployment points at the replica set. And if you, for example, push an update to a deployment, it sees that there is something different, like an image version, and it automatically creates a new replica set. And then when we do rolling update, which what the deployment does, is that it creates a new replica set, and in the new replica set, it creates one more pod and tries to start it. And if it starts, then it has 4 pods, but the requirement is to have 3. So it goes to the old replica set and removes 1 pod. And now we have 3 stable pods, 1 from the new version and 2 from the previous version, and then it just repeats. But if the new pod in the new replica set fails to start, then we still have the previous version running, and we get some metrics somewhere saying, okay, this didn't start. The service is still online, but if you want to upgrade, then you have to fix this problem first. So that's pretty much why we have deployments, so we can have reliable service, and we can easily go forward and back if we have newer version or we want to try something out and so on. In our setup, we kind of just roll forward all the time. So every time I push a commit, it will build, publish a new image, and then set up new deployment. And then if everything goes right, then we will have new replica set and new services running. Then from the point of view of incoming traffic, if we have many pods, then every pod has its own IP address, and pods are volatile, so they can die at any time, just like containers. And so you need somehow to assign them a common API, and that's why you have services. So there are multiple types of services, but we will be using cluster IP, which is like the most basic. It just assigns an IP to a group of resources, typically pods. They are called, I think, backends inside of Kubernetes. And so we have this service, but this service is still not accessible from the outside. So we need some kind of a broker or gateway API. And for that, we have Ingress. So Ingress is kind of all of this together. So it's like a reverse proxy, HTTPS termination point, and API gateway that can route the traffic based on the routes that access the server. It can also overwrite the URLs. So for example, here on the web, we are outside and we go to our ingress controller, which is at the edge of our cluster. There's probably some load balancer before it in the cloud, but that doesn't really matter. And we see, okay, this is API. So there is a rule that says, if this is API, then go to service 1 and rewrite the URL to be just slash. And then the service knows that there are two pods underneath it, so it selects one of them. When the default setup, it just goes around and around. And so it ends up in here, and this pod just handles the slash traffic and returns some resource, and then it goes back and gives you a response. So a typical API gateway. And you can also terminate HTTPS in here, but we won't do that right now because, well, it's not very difficult to set up, but you probably want to have your own domain, and then you have to have DNS challenges and so on. So it would be too much in this course. Any questions? No? Any questions on YouTube?
No.
Is anybody watching?
Yes. I'm too, actually.
All right. Next step. So now we're gonna put it in practice. So if you would be setting up your cluster in Azure, what you would need to first do is that you connect to it through kubectl. So then you can take the information about the cluster, put it in your GitLab, and that way you connect them together. So I will show you the commands, if it works. Zoom in. Where's my Azure? Yeah, I probably want to do this here. So this is how a dashboard of your Kubernetes deployment looks like, and here you have multiple options. It doesn't say kubectl anywhere in here, but if you click this View Kubernetes Dashboard, it will give you the full steps of going from nothing to having a functional dashboard, and you are connecting, and at the same time it will set up the environment for you so you can connect directly through the kubectl. If you look in here, it instructs you to install kubectl, and you can do it through this command, but I did it through brew because I want to manage the version in much easier way, so the package manager is better for me. This command here is AKS get credentials, and it will log you in. And here you want to take care about knowing which Azure subscription you are logging into, because, for example, I have like 3 of them and all of them are under the same email. So it's pretty difficult, and it takes a little bit of figuring out. But if we try it in here, where's the console? So here in the console window, we log in. It should. No. Okay, it says that I don't have the authorization. And if that happens, then you need to log out from Azure. So I do Azure logout. And then I need to log back in because I'm probably on a different subscription right now. So here you can click log out and forget if you have multiple of them. That way you will be able to select it from the start. Come on. And then I log back in. I use my personal one. Yeah. Now I need to confirm. Yep. And now we logged in. We can close this one down. Go back to the console. And to me it will say, oh, you have multiple subscriptions. Unluckily, this one is now active, and I know I need this one to be active because that's the one where I have the resources. So I need to do AZ account dash subscription. Is it too small in the?
It seems good.
Really?
Fine.
In the stream. And then I need to put in this ID. What? Probably set. Oh, there we go. I hope.
Do you want to audit information?
No. All right. So one more time. Yeah, right. I already have the profile, but if you did this, I will try to make it a bit bigger. What? Where are you? Configuration. There it is. Font size is 18. Let's hope. So this is the error message that I got. Normally you would get like a setup. I think I can just do -F. Probably not. Something like that. Somehow you can force it. Yeah, that's overwrite existing. That's very easy to write. And this will set up the context for my kubectl, and it will also set up the context for the Azure command line. So then I can use this command, which will give me an awesome dashboard of everything that I have deployed. But at the same time, also the kubectl is set up, so it will start a proxy locally, and it will route the traffic through the kubectl proxy, so we can look at the resources that are on the cluster, but we are looking at it as a user that we are logged into Azure. If we just went to the address that's hiding behind the proxy, we would get rejected because we have no authorization. And so here we have a namespace and we have all the resources. You can play around with this. It's very useful at the start when you are just trying to figure out what's happening. You don't know all the commands, and you just want to have a quick overview of what is there. So even if you click right here, you can see the logs of your server where it's listening. You can do the same thing through the kubectl as well. You just say kubectl logs and then the name of the pod, and you will get this output as well. Okay, I digress. So what we need here now is to get some basic information about the cluster, we need to get a secret from the cluster. That's the certificate of the cluster and the token that we will use to connect to it. And there is an awesome wizard for it in GitLab. Come on. So here, when we are connecting the cluster, we go here. We go here, Kubernetes. We will add a new cluster. I already have one, and you only get one for free, so I can only show you how it's already set up. But the exactly same information that you will need to input will be are here. So you need some name that you will come up with, the URL to your cluster. This one you see here, right here. And then you need the certificate and the token. I won't show you the whole content of my certificate because I'm not crazy, even though I will tear it down later. But I will show you the commands that you need to issue. So you need to do kubectl get secrets, and that will list all the secrets that you have. Maybe we can first do like, even try if we have connections. So we do kubectl get pods, and I can see that I have some pods. You can do something like cluster info or whatever you want. This is probably not the best command when you are just trying it out, because you will get no resources. So you can do kubectl get secrets, and this should at least show you some stuff, so you know that you are connected. You would probably get an error anyway. So what just happened? No. Right. And this lists the secret, and you will need this name, because then if you do kubectl get secret and you put in this name, it will show you the whole output. And you will also need to specify that the output should be YAML, because then you can see the certificate and the token base 64 encoded, and then you can just decode those in the command line or on some like tool. Probably not online tool, maybe they want to scrape off your certificates, but if you want to do it on Mac, well, this is how. This is kind of how the, where is it? This is kind of how the output looks like, and you take the item from the CACRT, and it will probably end with an equal sign, or maybe not, depends on how many characters you had. And you want to decode it, so on Mac you can do it, for example, by echoing into base 64. Come on, go away. So if you do echo -n, then you put in the whole content, and then you do base 64 decode, you should get something like this, but the secret, it will be your secret. In the token, there is no the begin certificate and certificate. And then you put it in those two columns in the form, and hopefully, if everything works together, it will connect, and you will be happy. You can also specify this namespace. I recommend you to do it, because then you have a control over the name. If you don't specify it, it won't go into the default namespace. It will just generate one for you. So you'll end up with something like smart-154 or something. That sucks. And then it also says here role-based enabled cluster. It's actually a role-based authorization control enabled cluster. And you can specify that when you create the cluster, but on the start, you probably don't want that, because then you would have to set up permissions for everything that you want to do. And for beginner, if you don't even know what you are trying to do, it's very difficult to set up the permission for you first and then know, like, this doesn't work because I don't have the permissions. Even though this is checked, I don't have that enabled on the cluster. So this is just some misinformation, or maybe just an option. So when you save that, you will get this. And here you need to install at least Helm Tiller. Helm is like a templating language for Kubernetes, and it enables you to build so-called Helm charts, where you connect multiple applications together. I won't be showing that because personally I don't understand it yet. And then you have Ingress, which is like the proxy that proxies your traffic. And then we have Cert Manager and Prometheus. I have them installed, but I don't use them in this demo. So that's something for you to learn as well. Yeah. One more tip: if you set up the namespace, then you probably want to configure your context. So in the kubectl, you have the context and you can list all of them, but by default it won't set up your namespace. So every time you do a query, you would have to say like -n and the name of the namespace. So with this command, you can just set it there directly. So this will be your default namespace from now on. And so every time you just do a query, you will get it from that namespace and not the others. Yep. Questions? No? YouTube questions?
No.
So first, deployment. I already did quite a few steps, like I built the images for the applications that I have, but I want to start from the actual deployment with no parameters, just like if I had just the cluster and just my command line, how I would get applications in there. So we can see the different pieces and then we can modify them so they are configurable. Okay. So this is how my solution folder looks like. I have a Docker file for the backend. It's really simple. I just copied it from the Microsoft link and just changed the way we copy it in there. So instead of using publish folder, I'm using folder that's called out. And then I named it based on the DLL that I have in my project. But the important part here is this Kubernetes manual, where all the stuff is that we need to configure. So before I was talking about deployments. If I can find the graph again. Maybe I can't. Where are you? Smart. Nope. There it is. Maybe. So this is our deployment. We have a deployment that we defined, and we have a replica set, and then we have multiple pods underneath it. And underneath the pods there are containers. So we need to define all of that in the deployment. Well, except for the replica set, that one is automatic. You can get a template for this, but for me it was easier to just take a documentation and just go line by line and see what I want. The little bit confusing stuff is that often they use like names and labels for all of the services the same, and then you don't really see what's connecting where. So I'm calling the deployment like API-deployment, and the pods I'm calling API-pods or pod. So you can see what's what and what's selecting on where. So it's not that confusing. So first we give the deployment a name, and underneath here you would probably see few labels in the production. I will show you that later. So this is like the minimal example of what you probably need to do. And then we have the specification for the deployment. Go away. So the selector here is what selects what will the deployment be managing. So we specify everything that has name API pod will be in this deployment. It might be in different replica sets, but it will belong to this deployment. And that's actually what we want. We want one deployment, multiple replica sets, so we can do rolling updates. So if you would have a label that would be version, don't put it in the selector. The selector should be immutable. So choose few appropriate properties of your pod or labels, like name of it, and if it's part of like a backend or whatever, and put it there. But if there's something that's changing on every push, like a version or commit SHA, then don't put it in the selector. And then we have a template. Template describes the pod. And the kind of weird thing in here is that you have a template and you have some labels on it, and then you have the containers, and some of the informations repeat. And this is because the template needs to be able to select on the containers, but there is not like an idea of if this is set in the template, then it must also be on the container, so there is no inheritance. So sometimes there is information that you need to repeat, and then when you don't and you try to update the YAML, it will tell you, no, this information is not the same, even though it's like in the same file underneath in the section in the YAML. But that's how it is. So this template has some metadata. It has a label name. That's what we are selecting on. And then we have container that's called backend. It uses this image from my registry that's on GitLab. And it uses this concrete version because I already had it built, because I started from the other deployments and then I just simplified to this one. Then we have some resources. This is here just because that if I delete it, it will give me a lot of squiggly lines complaining that I will exhaust all my resources with just 5 pods in the cluster. And then we have environment, which is an environment for the running container. So if we need to communicate some information to the container, make something configurable, we can use the environment variables to do that. So for example, I broke this application and I'm like pointing the service at port 5000, but I forgot to define it inside of the actual service. So since ASP.NET Core can be configured through environment variables, what I can do is that I just change the environment variables in there. So they will be ASP.NET Core URLs. And if I apply this deployment, it will restart my pods, or actually probably create new ones. And it will give them the correct configuration and it will work. So you can configure it from the outside instead of committing the code, pushing it in the repo, and then waiting half an hour, hoping all the tests will pass, it will deploy correctly. No, you can just declaratively set it up in there, push it, and in a few seconds you have running service again. So deciding what should be configurable externally, like all the secrets definitely should be outside, but you can also optionally change some options like I'm doing with the ports here. Then we have this ports section, which is not needed actually, but it's nice to have so you know what you are expecting from the container to be exposed. And you can give different names to the ports. So for example, in my dev production environment, I have port that's 5000 for the traffic, and I have 5005 for the metrics, and I only expose 5000 outside for the ingress. So ingress only goes to 5000, but the internal info is also public within the cluster on 5005. So I don't have to write like authorization for it. But yeah, if you remove it, it will still work. And then we have this image pull secret. And that's quite important because you have a GitLab registry in here where you push your images, and then you have your Azure cluster on a different network, and you need something to be able to connect to the registry and pull the images. And in here, I'm just using my username and a token that I pushed in the secret storage. You can do that by kubectl create secret. I probably have like a full example in here, actually. Yeah, there it is. So you need to specify the Docker server, the username, your email, then the password that you use, or if you are using two-factor authentication, you need to use your access token. But this is only if you want to deploy it manually from here. If you do it directly from the pipeline, then you have built variables that you can use for it. One of them is short time lived token that you use to write in the registry, and then you have long lived token that you use to pull from the registry. So that's much safer, and it's configuration free, and you don't have to set up anything yourself. We will get to that as well. What's the time? Wow. Okay. Only 3 more hours or something like that. So here we have the deployment. I will try to deploy it. I will try to deploy it without the fix, so we have something to look at. And so I go to, okay, smart, that's nice. So where's the window? No. That might solve the problem with you not being able to see it. So one more time, I go to Kubernetes manual because that's where my manifests are, and then I want to apply the one that's API deployment test. So I do that via kubectl apply -f, and then the name of the file, deployment test. So this will like what's the word? Declarative. That's that. Not imperative. So this will tell the cluster, set it up in the way it's described in the file, and it will figure out if there are any changes to do, like if it's different from if this is different from the state that's there, and it will apply some changes. So I will do that. It will think. And it says configured, which means I changed some option, but it was already there. If it said created, it would mean that I created it. And if I do it one more time, it will say unchanged. So nothing changed. You just apply the same thing. And this is extremely useful when you are deploying stuff, because then you can put it in your pipeline and you can just say, I want to apply everything from this folder, and it will just figure out what it needs to do. So you don't have to specify every new service in your build step. So now we have the deployment. Hopefully it's running, but how do we know? So we have no ingress, we have no way of reaching the service from the outside, but there is one way to reach it, and that's the same way that the dashboard works. There is a proxy that allows you to access everything that's inside of the cluster. And we can start it very easily. So by doing kubectl proxy, and I'm just going to specify a different port because maybe the other one is taken by the dashboard. And if you want to like work with this and also have the dashboard, then this is useful to specify a different port. So you can access both at the same time, and I need to put it on the screen, right? Yeah, that would be useful. So kubectl proxy -p 8002, start that. It will just start serving at the localhost, and I can go there and look what it did. Localhost 8002, and it just shows me a lot of APIs. Okay, but those APIs are like the highest level REST API, so you can navigate them through the hypertext navigation protocol. So we go to like API version 1. We can list everything that's there and decide what we want to see. So like bindings, components. I know I want namespaces. So I look at namespaces. Okay, so I probably want the namespace smart def. So yeah, that doesn't work because I didn't spell it correctly. So smart def. Okay, so which resources are there? And so on. I will just copy it from the prepared command if I can find it. Yeah. So in the end, it will end up looking something like this. So we have API, namespace, SmartDev, then we go to pods, and then we have to specify the pod name. So we list all the pods, and we try to guess which one it could be. So we just, come on.
Can go also to services.
Yeah, but right now there should be no service. We just deployed a deployment. But we can look at deployments. Maybe there will be some useful info. No. What am I doing wrong? That's the version 1. Yeah, you would have little less resources than I have. I will just gonna list it in here. kubectl pods. And I want this one. API deployment something something something. That doesn't seem right. 20 hours? Maybe? Come on. So go here. Then we specify proxy, and then we should get something like connection refused. Yeah, that's what the server says. Because now we see that we get response from our ASP.NET Core server, so we are only waiting at API, and it's also refused. So we are going to 5000. Something is wrong. So what we can do is that we look at the logs. So we can do cube ctl. We give it the pod. We say logs. And it says I'm waiting on port 80. So we need to connect on port 80, not port 8000. 5000, because that's what the deployment says. We are going to port 5000. Luckily, we don't have to redeploy. We can just specify the port in here. And then we get not found. Why? Oh, okay. It's directly on that, not on /API. So this is finally the response from our pod that we reached from the outside without having to make it accessible through ingress. It's very useful if you want to debug something or you want to have like some internal services like a monitoring that you don't want to hide behind authorization, because then you would have to do it yourself. This way it's just safely inside of the cluster and you can access it as an admin through this. Yep. And you also saw how to list the logs, which is also very useful. So it's just kubectl logs, then you don't specify the type of the resource, you just specify the name, you get the logs. Now we want to make it accessible from the outside, so we need an ingress rule, and we firstly need a service. So here's the service. We specify it as a kind service. We give it some name. We call it API service. And then we again have a selector that selects the pods. So if you remember the graph, there is a service that's pointing to some pods. So that's how we do it. We tell it, here are the pods that you should be managing or sending traffic to. Again, we don't specify any version, but we could. We could have like this is the service for this version of the pod, this is the service for this version of the pod. But probably you don't want to do it when you are doing like rolling updates and you don't want to change the internal IPs every time you publish a new version. And here you can say which port the service will accept the traffic at, and then you can push it to a different port that will be on the pod. So that's why it didn't work, because the same way as in the deployment, well, we will see that. But our container right now is listening at 80, and now we have 5,000. I will just fix it because otherwise it would just take a long time. But yeah, if the container would be listening at 5,000 and we set 80 in here, it would work, wouldn't it? I don't know. Let's not get into it. Let's just deploy it and see if it works. So I will do kubectl. This is probably the first command that you will alias. So I have like calf, get, and so on. This is how it looks like. Alias grab kubectl. That's why I can type it. So this is how I talk with Kubernetes. Like kgp get me all pods. So kubectl apply -f, and then it is, we are in the different folder again. JSmart. Okay, finally. kubectl apply file API service. Now we configure the service. So now we have it. Now we have the IP. We can list it by doing kubectl get services. And this is all the services that we have internally. This one is the one that we just configured. And now we need an ingress rule to point at it, so we publish the traffic, or we are able to get the traffic inside of the cluster. So you probably will make this file for every entry point that you want to have, and later we will make one for every different subdomain that we will have. So here I'm just defining the basic template. This is important. Sometimes, well, what this does is that it changes the URLs. So if you if you send a traffic that's on /API, it will just send / to the service that's listening, and then to the pod. So then the pod doesn't have to know where it's deployed or how it's deployed. You can tell it by environment variables, but you don't have to bake it in the application. And also make sure that you know which type of ingress you are using, because then the annotations will change. And if you don't have the correct ones, then it's very hard to find out what's wrong, because it will just reject your traffic. Here we have a few rules. So this host is the public API that Azure gave to the ingress when we installed it. If you go to GitLab, it will helpfully tell you what the IP address is in here. And it also tell you if you don't have your custom domain name, you can just use public reverse proxy like nip.io or xip.io. So then you just give it your IP address .xip.io and you will be able to reach your services. Because if you don't and you just provide IP address to Ingress, it will reject you and it will tell you I need a host name because I cannot work with IP addresses. So that's where that comes from. And then we have just few rules that say if you go to path API, then go to API service, like in your normal API gateway. Okay, so let's deploy that as well. kubectl apply -f, and then it's ingress test. Do it. Okay, if we want to list this, then we can do kubectl get ing, and we can see where we are listening and how we can access the services. So with a bit of luck, we will be able to go to this address and access the service on the backend. Hopefully. Yay. And it says default backend because something is broken. I don't want to debug that, but I think it's just one of the ports. 80, 80. This is 5000. This goes to what?
Aren't we missing an API, like the path on the end of the rest?
Ah, right. Clever boy. Yeah, you get it. Plus points for you. So yeah, now we are coming from the internet to our cluster through Ingress. We are routing the traffic. Everything is awesome, and this is pretty much what you need to do. So now we need to parameterize it to make it deployable in different ways. And this is not very difficult. One approach to this is that you learn how to use Helm, how to use the templating language for this, and write it that way. Or you use the thing that you already know, which is probably regular expressions, well, text replacements, not regular expressions really. And so that's what I did. So here's our GitLab CI YAML, where we define a lot of stuff. One of them is this host, and how we build the backend. We can go into that later. And then we deploy. So this is how we deploy the whole application. First of all, I'm running in a Docker container. This container requires me to specify the entry point. I don't know why, but that's how it works. With some other containers, it works correctly. But if you don't, then you will get an error that says sh is not a kubectl command or something like that, because when GitLab is using this container, it tries to push some setup on it, and it doesn't work. With few other containers it works, but here you just specify that you don't want the entry point to be kubectl, you want the entry point to be just shell, and then execute the commands that are after it. Then we say it's in the deploy stage. So if I show you how my whole deployment looks like, or the pipeline, it looks like this. For example, this one. So I build the backend, build the front end, publish backend. That means push the image into the registry, push the image of the front end into the registry, and then I deploy everything. So it just uses kubectl. I will show you the commands in a second. And then I have another task that is linked to it that just calls the commands that will delete everything from the cluster. Well, everything that belongs to this environment. And we can define where we want to run this. So if we wanted to have one process for master and one process for the other review branches, which is how I have it set up in my environment, but in here it's pretty much just all the same steps, but yeah, it pretty much does the same thing, but I can like change secrets or do different stuff, give it different configuration for the DB or JVT or HTTPS, but it's exactly the same idea. Then I use extensively the environment variables that the build server gives me, and there should be a link somewhere. Let's see, GitLab CI and vars. So here the list of all the variables that you have is, and also if you scroll down, this is very useful, you get examples of what is in them if you want to use them. So I didn't know that, and I was always like, typing it in, printing it into the pipeline, and then I just realized, okay, there is a whole list of everything that's available, and there is like a lot of them. So here I'm using the reference name to name the environment, so the name of the branch. Then to make the URL, I'm using ref slug. Slug is just URL friendly version of the branch name. So if you have like special characters in it, or I don't know, spaces are probably not possible, but like percentage or something, then it will just trim it away and it will make it lowercase. So it's like a proper nice URL that you can use and remember. And then this is how we link it to the other task that stops it. And then few more variables. This is the host that's on the top. So that's our IP. And this is what I use to deploy the front end, so I can tell it where exactly it's running. So we will get to that later. And this is the most important part. So here in my manifests, in the YAML files that I deploy, I have those tokens that will be deployed with the real version, like in here with the branch name. And that's the whole magic. Like you take pretty much the same files as in here, and you just add like a, come on, word keyboard. Slug everywhere where you want this to differ, and then you just replace it and do the same deployment as we did now. And then it just depends on the branch. And if you give it a label that will link all the environments together, then you can just select all the resources together and delete them together or restart them together and so on. So that's what I do on every deployment. Where is it? So set is a tool that replaces the text. The syntax is terrible. But this tilde, normally when you will see an example, there will be like a / probably. But in your URLs, in this one, I already have /. So there are like 10 or 15 different separators that you can use, and this is one of them. So instead of using / to separate the commands, like the replacement and the text that will replace it, I use tilde. So that's why it looks different than you might see on the internet. And then it just goes through all the files that are in the Kubernetes folder, replaces the text, and then calls apply. So that creates the environment that's depending on the branch. Questions? Simple? Yeah. And so this is how the files look in real life. Pretty much the same as the previous ones. Those are just some labels that are recommended by Kubernetes, so the tools can work around them and give you a better overview because you give them more information about what you are trying to do, what's part of what, and so on. Here's my version that's taken from the short SHA of the commit. And in here, I actually have the version, but in here, as I said, I don't want to specify it because this selector should be immutable. So it covers all the replica sets and all the pods. And then it's just the same idea. more labels, just what we did before, but with more labels and replacements. In here we have registry, and I will just try to put it next to it. So we can compare what will end up where. Yeah, that's not very nice. So the registry here is CI registry image, and that's pretty much the whole name. But so there are like 3 levels. You have your organization in the GitLab, then you have your name, your project, and then within that you have something else. We can look at the examples. Registry image. So this is how it looks like. So this is what's in there, so it specifies exactly where your image is with the registry syntax that normally Docker uses. And then I'm just adding like a slash backend, which is name of the image, and then I tag it with the short commit ID, which in turn, so this is the short commit ID, which in turn makes this template different, and so then Kubernetes knows, okay, this is a new version, so I will have to deploy a new replica set for it and go forward. If I didn't do that, I can manually like tell it, yeah, this is different, just deploy it again, instead of just thinking it's the same, but this is very easy to do. And it also gives you exactly the information about what's deployed, because then you can easily look at your commit history and know where exactly this thing is coming from. And yeah, that's about deployment, so just the replacements. With the secret in here, we have registry secret. So this secret is the deploy key. So if you want one, you can, let's go back. This registry secret is applied in here, and I'm using the built-in environment variables. I could also create my own variables, populate them with the token IDs and put them in here. But if I want it to work automatically with the built-ins, I need to go to my setup settings repository, I think. Yeah, here deploy tokens, so it allows read-only access to your repository and registry images. And I need to create one that's called exactly like this, so GitLab deploy token. And that will connect it together with the environment variable, automatically populate it with the secrets, and it will work. If I generated another one, I would have to go in the CI/CD settings, environment variables, and like create a new one, set it up, and then use it in the build, which is just too many manual steps for me. But this section is very useful if you want to provide additional information. Then I usually just put it in here and then apply it as a secret through this, which first tries to generate it and then it applies it. So if it already exists, it will be overwritten, and if it doesn't exist, it will create it. If you would do it without the apply at the end and you just try to create it, it will fail if it's already there. So this is like a nice way of saying, yeah, replace it if it's already there. And yeah, there is another secret that I originally used to do the deployments as well. But this secret is read-write, and it's short-lived. So if you give it to your deployment, it will or will not fail. You will see. Like in the production, if you go through the pipeline, it lives through the whole pipeline, and you can use it to publish your images. But then if you use it as a secret to like deploy your stuff into Kubernetes, and one of your pods will restart, it will no longer be valid, and the pod will just die because it won't be able to like get the image or something like that. So you want to only use this for publishing your images, and you want to use the deployment one, which is somewhere here. What? Where did I put that? Well, the thing that I showed you before. So deployment is for deployment, and this one is for publishing. All right. No questions so far?
No.
Yeah. Close. What? So maybe we should try to push something. So, yeah. Same thing as in the previous deployment, same thing as in the manual service, and then the ingress is just, well, not in here, but I will check out the branch where we have the front end as well. So here we have a front end as well, and we have more paths. It's not very exciting, it's just 2 items, but you can have quite a few. And so you want to order these paths, I think, based on like where they will match, because if I put this first, it will match first, and it will just put all my traffic into the first service, which is not what I want. And then the thing with the front end. So here's my awesome front end. It kind of simulates what you would do in like a front end framework. Well, not this, but you would have HTML application, you will have some JavaScript that will be downloaded from the server in a bundle or separate file, and you would probably have some environment file that would define where your backend is. And so the problem that I see a lot is that you have multiple images, and that's because when this is in your environment file for the production, and then you do optimized build, it will take this URL and put it directly in the HTML and JavaScript, and then you just like point directly to one place, one server, and your sources and your image is tied to that one server, and that really sucks because then you cannot deploy it into multiple places. So what I do instead is that I define the URL, for example, like this. So I have, again, some token in the URL. When I build it on the server, it will bake in the HTML, so it will be there, it will be in the image. And the URL in the image will say, like, exactly this. And then when I start the server, I just go through all the JavaScript and HTML files. There's like 5 of them usually. And just replace it. So it takes like 10 milliseconds, and I can push in the environment variables and URL based on the environment variables. And then I'm happy I have only one image. I can start it anywhere. I can tell it where it's running, and it will serve it directly to the front end. So if I decide to move it like on a different URL or like on a different not subdomain, well, even a subdomain, then I don't have to change anything about the image. And it also, like, I can build it, test it, and deploy it, and not build it, test it, then build something else and deploy that, because I want to bake the URL in it. Yeah, makes sense? Do you do that the same way? Cool.
And when do you replace it on container start? Or?
Yeah. Well, when the server starts, I just wrote it in .NET, but you can do it in whatever you want. It's pretty much about the concept. Yeah, is there anything else that I want to show? Accessing services. No, I think that's about it. Questions?
What was the latest record, the GTR Alpha?
Right, that one is, if I can start the thing again, so if I do kubectl get deployments, wow, I hate spelling that. So this is one of them that are deployed. Kubectl describe deployment. Wow. Is it in here? Probably not. I thought it is. So it writes an entry somewhere that says which command triggered the change. So if you don't put it there, it will just say it changed at this time, but it won't tell you like from which command, from where. I'm not sure if it's very useful for the overview, but maybe it's coming from a different one. Let's see. Probably not. Okay, yeah, I know you can see it in the dashboard, but I don't want to start right now. So it just records more information about what happened. I just saw it somewhere and I thought it's cool, good to know. If you can just put it there, just do it. So I did that way. More questions? YouTube, nothing?
Nothing.
Fun. So yeah, that's it. Thank you for coming.
Thank you.